Now we're going to get to the good part, expanding algebraic expressions. It's one of those things where you just have to constantly expand expressions in a variety of topics in this advanced course. So make sure you're quite competent and you have a sort of a mastery in terms of expanding any type of expression that we throw at you. Now in this concept box over here, we're going to summarize some of those key skills that you would have seen in the past. So we start off with the distributive law, which is basically your normal expansion. So let me just get my highlighter out. So this very, very first one over here is if you were to expand it normally. So if you have k on the outside and you've got a plus b on the inside, you would distribute and expand and multiply that k through to each of those terms there. So you can see where the ka and the kb comes about. Okay. So if we move back to the one underneath there, so I'm just get rid of that first. So this one over here is when you have a binomial product. Okay, so the way you would do that is you would take the first thing in the first bracket and you will distribute it and expand and multiply with each of those terms there, the C and the D. So that's going to give you these first two things there. Secondly, you're going to take the second thing from the first bracket and you're going to expand in that same order to give you the back end of that. And when we do an example, I'll explain a little bit more how you will get these sort of answers, but I'm just briefly recapping some of these rules. Speaking about rules, we then have a couple of special sort of expansions that's worthwhile remembering because these are your quicker way to get to the answer and not having to rely on those first two, specifically this type of expansion here, because that could be quite a tedious process. So the first one is when you have a situation of perfect squares, right? Whether it be addition or subtraction. So the first thing I will say here is I'm looking at this one over here. So if you have a situation where you have a couple of things in a bracket that's being squared, it's going to give you what we call a trinomial, and it'll be in the form a squared plus 2ab plus b squared. Now, if it was minus, so the one underneath there, you can see the only difference here really, if I can emphasize this, is just that minus there, that minus sign over there. Okay, but it still follows that same suit. And when we do the examples, I'll illustrate exactly how that looks. Now, the last sort of expansion technique here is the difference of two squares. That's when you have a situation where both of these brackets that you want to expand kind of looks the same, but one's a plus and one's a minus. It actually just turns into, or simplifies to, a squared minus b squared. So that's why we call it the difference of two squares. So that was a very, very quick sort of overview and recap of some of those expansion techniques. Often enough, it's just a bit easier that we go straight into the first example so we can illustrate how to use them and what these abstract rules might sort of look like. So let's zoom into question 4a and write down part A, right? So we've got 5x squared outside of 4 plus 2xy minus y squared. So to expand this, we're going to be using the distributive law, the first one. So the 5x squared term is going to be key because we're going to basically multiply that by that, then that, and because we have three terms in the brackets, we have to multiply it by that third term there. So following the first orange arrow, we're going to have 20x squared. So 5x squared times 4 is your 20x squared. Now the 5x squared multiplied by the 2xy, so my middle term, and I'm going to just get rid of that little marking there, would be plus 10x cubed y. So that will give me my middle term by multiplying that middle orange arrow. And lastly, to follow the final one, 5x squared times negative y squared, that will be negative 5x squared y squared. Right? So we're just using our distributive law to expand each of those terms inside the brackets there. All right? I might just get rid of these arrows now so it doesn't look too messy. So just bear with me for a quick moment. Let's move on to part B then. So for part B, we've got a 7 minus 3x plus 2. So for this one here, we only have brackets in the latter half of that question, of that expression there. So that means I'm not going to do anything to the 7. I'm just going to worry about expanding the back end of this question here first. So you got to be careful here, right? It's a negative 3. So just to clarify, any plus or minus sign that you see there belongs to the term following immediately afterwards. So it's more correctly to say it's going to be negative 3 times x, which is going to be negative 3x. I'm just going to write that down before I forget. And then it'll be negative 3 multiplied by positive 2, so that will give me my negative 6. Okay, so I've done the expansion. I probably want to simplify things. I can see a couple of things that's like terms. The 7 minus 6 is 1, so it'll be 1 minus 3x. Cool, let's keep going. So that's part B. Part C, I think I'm just going to squeeze one more down here. I'll do part C. So I've got to look at the question again. We have 2x minus 5. So it'll be 2x minus 5 and then x minus 3. So this is our first binomial product. Basically, we have two brackets next to each other that we're going to multiply and expand them out. Okay, so the way it works is you start off with the 2x and you're going to expand and distribute it to the two terms in the second brackets. So 2x times x is 2x squared. 2x times negative 3 is negative 6x. And now, because we've dealt with the 2x, we're going to do the same thing to the negative 5, and we're going to distribute it into that second bracket. So negative 5 lots of x is negative 5x. Negative 5 lots of negative 3 is positive 15. Have a quick scan in the answer there. Can we simplify things? Yes, we can, because these two terms in the middle here are like terms. So always simplify. So the 2x squared remains. Negative 6x minus 5x is negative 11x. Plus 15. Can't simplify that anymore, so that will be our final answer. We're doing very well. We're going to move on to part D. And part D, we're now going to be looking at our special binomial expansions. All right, so the first one is a perfect square. So we're going to do this the quick way. So we're going to use the rules for perfect squares to get the answer in basically one step. Now, because it's been a while, what I'm going to do is I'm going to do 2 steps. But once you become competent at it, this first step that I'm going to write down, you almost never need to write that down in a test. But for everybody's sort of benefit here, I'm going to write down the full working out. So the way the perfect square thing works, and I might just emphasize this, I think what I had previously is it will look like this. So this that I'm writing down is the rule for the perfect square, and we're going to follow the back end of that. That's going to give us the answer. So what it's telling you is you take your first term, in this case 3x, and you're squaring that, so it'll be 9x squared. Okay. In fact, I think I'm just going to, like I said before, I'm going to do the full working out just for everybody's benefit. So I'm going to emphasize and say it's the first thing you have there, but you're going to square. So that's sort of synonymous to your a squared in the rule there. Then you're going to have a plus 2, and then you're going to write each of those numbers, or I should say terms, in the middle there. So instead of 2ab, it is instructing us to write down 2 lots of the 3x, and then the plus 2 at the very, very end there. Plus b, which in this case is 2, but you're going to go ahead and square that. So you can see it follows that trinomial form. All right, tidy it up. 9x squared. So that's going to be 12x, and that's going to be plus 4, and that's going to be our expansion. All right, so this is using the perfect square rule to get the answer as quickly as possible, and we don't have to waste time doing the long sort of expansion. All right. Like I said earlier as well, so this little step, this intermediate step over here, once you do enough of these questions, that step is not needed. That's kind of like in your head doing the sort of algebra, and you're just writing the 9x squared plus 12x plus 4 as the answer. Now, to illustrate what I mean by that, as in you don't really need to write that down, is I'm going to do the next one, which I believe is also a perfect square, and show you exactly how I would sort of mentally visualize what I need to write down the answer in one step. So for part E, it is a binomial, sorry, it is a perfect square, but it's a minus, right? So 2x minus 5 all squared. So I might just, for everybody's benefit, I'll just quickly write down the rule in the concept box. So if you have a minus, it follows the same structure, but you just have that minus there, right? So plus b squared. Just notice that's off the screen. I should probably zoom out. Hopefully the other one wasn't too far off. Now continuing on, this is what I would do. So the first term that I have is 2x, but I know I have to square that term. So that's going to look like 4x squared. And I write that down before I worry about what the next term is going to look like, right? So that's the first part of my answer. The middle term is going to be minus two lots of the product of the 2x and the 5, but make sure you double that at the very, very end. So 2x lots of 5 is 10x, so it'll be 20x. So just to clarify, you multiply those two together, so the 2x by the 5, but then you make sure you double that, and that will form the middle term. So it'll be 20x. The last one is your b term, so it's -5 that you're squaring. So that will just be plus 25. That's the easy one. All right, so there you go. We can do that without that intermediate step to get our answer in one go. That's what we want you guys as advanced and extension 1 students to be able to do now that you guys are in year 11. All right, which you probably have been doing in year 10, but just make sure for everybody, that's sort of the standard when it comes to expanding things now. I think there's one more. Yes, there is. There's a part F. So I might just squeeze. I'll write the question, then I'll zoom in again. So we have 7x plus 2 brackets 7x minus 2. So this here is the difference of two squares, if I can zoom in properly, right? So just to clarify, we are looking at the situation where it's like you have two brackets that's kind of the same, right? But it simplifies to the difference of two squares, which I'm just going to move that across. You can see that easier. So we're going to go ahead and expand these sort of brackets here. So what it's saying, if we want to do it quickly, is you take the first thing you have in the brackets and you square that. And you're going to subtract that with the second thing you have in the brackets, but square that as well. Right? So this is going to be your 49x squared minus 4. Nice and simple answer. That's using your difference of two squares. All right. So what we've done in here is we've basically revisited how to go about expanding various expressions. The key part for you guys is make sure you use your perfect squares and your difference of two squares when it's in that form for you to get the answer in one go. Don't do the long way of getting it and expand everything out. Hey everybody, if this video helped you, make sure you subscribe to the channel. It supports the channel and helps me keep making more free content for you. I'll see you guys next time.